Okay, in this problem, we have water is going to go, on most of these we had 102 degrees Celsius. We're going to convert it from 95 grams of liquid water from 26 degrees Celsius to steam at 102, which means if we look at our curve, right, we're going from 26 degrees in the liquid phase. So we have to go up here. That's an MC delta T part. Then we're changing state. That's a delta H fusion. And then we're going up on the steam to a final temperature of 103 degrees Celsius. So the energy, calculate the amount of heat needed. That's what we're looking for. So we have the amount of heat needed is going to equal the MC delta T when we're in the liquid, plus the delta H vaporization, plus the MC delta T when we're in the vapor. Okay, so we're given that it's 95 grams, so we know that M is 95 grams, and the liquid is going to go from 26 degrees Celsius to 100 degrees Celsius, because that's when we're going to vaporize. And the steam is going to go from 100 degrees Celsius to 103 degrees Celsius. And we're given our specific heats for liquid and for steam. And we're given the heat of fusion, which we don't need, because that's if you're going from liquid to solid, which we're not. And we're giving the heat of vaporization, which we need. And it's given in kilojoules per mole. So we know that delta H is equal to 40.7 kilojoules per mole. Okay, so we're going to plug in here the MC delta T. We're going to do 95 grams times 4.18 joules per gram degree Celsius times 100 minus 26, which is 74 degrees Celsius. Okay, so that's this. Delta T is 74. Plus, now delta H vaporization, we need to multiply this 40.7 by the number of moles. So let's convert 95 grams times 1 mole for every 18.02 grams for water. So these should say water. And we'll find out that we have 5.27 moles of water. So if I multiply 40.7 kilojoules times 5.27, I'll get kilojoules. So 40.7 kilojoules per mole times 5.27 moles. And then, put a little bit of paper here so we can go to the right. We have to add the mass, 95, times the specific heat of steam, which is 2.01 joules per gram degree Celsius, times 2 degrees, because you went from 100 to 102. Sorry, this should be 102 over there. Okay, so degrees Celsius. Degrees Celsius cancels, grams cancels, moles cancels, degrees Celsius cancels, grams cancels. So I'm going to add joules. That's all that's left there. Plus kilojoules. Oh, I have to change this to joules in a minute. Plus joules. So let's figure out what these numbers are. So we have 95 times 4.18 times 74. This becomes 29,385 joules. Plus, that's what this one is. This one, 40.7 times 5.27, and we get 214 kilojoules. So I'm going to just add the zeros on now. And then for this one over here, we get 95 times 2.01 times 2, 382 joules. Okay? Now when I add those, you should get 214 plus 29385 plus 382. 243,767 joules. It's too many sig figs. So these were not significant here. So if you had 244 kilojoules or something in there, I actually didn't take off for sig figs on this one, but those are the answers for this problem.